Hello. Today we're going to be talking about standard 8.G.7. And in that standard, we're going to be applying the Pythagorean theorem to determine unknown side lengths in right triangles in real world and mathematical problems in 2 and 3 dimensions. We're actually going to be talking about the like a real world 3-dimensional, but on paper it's going to be a 2-dimensional project or equation, if you will. So we have ourselves a tree, okay? So bear with me on the tree that I'm drawing. Alright, so we have ourselves a tree. Alright, and once again, like I said, I'm not the best artist. And it has a shadow of 6.2 meters. Okay, and we know with a special tool, if you will, that from here, top of the tree, to the top of the shadow is 7.5 meters. And right here, I'm just going to use an M for short so we don't get writing into our picture. Well, to find this out, the Pythagorean theorem states that a squared plus b squared equals c squared. So for this problem, we'll make the tree our a length, our a side. The shadow will be our b, and the hypotenuse, or this line going from the top to the bottom, top of the shadow to the top of the tree, is going to be our c, and the hypotenuse will always be c. Now with that being said, our a squared is still unknown, so we're going to leave it at a squared. Our b squared, b is 6.2, so then we'll square that, and it'll be equal to 7.5, and we'll square that as well. Okay, so I have our calculator here, and we'll just bring that over. Keep them next to each other so we can reference. But we'll type in what 7.5 squared equals. So it's 56.25. And then we'll type in what 6.2 squared equals. And that's 38.44. And already we can kind of see we're not going to have a very pretty number, but we will have a number for how tall the tree is. So simple, our algebra will have us subtract 38.44 from both sides. Alright, and when we do that, so 56.25 minus 38.44, that gives us 17.81, and that equals a squared. Now to get rid of the squared, we'll just root that. Okay, and so we'll square root 17.81. That gives us this long number, and we'll round it to the hundredths place. So our tree in meters will be 4.22, and we can't forget our unit, which is meters. Alright, and with that, we'll just go back over the standard really fast. We were able to apply the Pythagorean theorem to determine unknown side lengths in right triangles, which is what we had here in our tree, and we used it in a 2-dimensional sense.